Video 2, Coordinate Geometry in the XY plane. We'll look at three things in this lecture. The first one is going to be calculating the gradient of a line joining 2 points. So the gradient of a line, we can work out the gradient of a line if we know 2 points on it. Remember, the gradient is the rate of change, so it's when you go one across, how many up you go. So if we got 2 points, we call the first point, we call it x1, y1, and the second point we will call x2, y2. And this little formula here, m equals y2 minus y1 over x2 minus x1, is how you find the gradient. The gradient is m, it's the change in y divided by the change in x. It's a formula that you need to remember. So there we go. There's point 1, x1, y1. Point 2, x2, y2. And if you work out those differences, x2 minus x1 is the difference along the x-axis. y2 minus y1 is the difference up the y-axis. And then we find the gradient by doing y2 minus y1 divided by x2 minus x1. So calculate the gradient of a line which passes through 2, 3 and 5, 7. If I was answering this, I'd make sure I'd write down the facts first. So x1, y1 is 2, 3. And the second point, x2, y2, is 5, 7. It's a good idea to write down, to change the question from a sentencey question to just the sheer mathematical facts in it. Once we know what the 2 points are, then we can use the formula y2 minus y1 over x2 minus x1, substitute in the values, 7 minus 3 over 5 minus 2, make sure that you are consistent and get the values the same way around in the numerator and the denominator. Work it out. It's 4/3. Example 2. Calculate the gradient of the line which passes through minus 2, 7 and 4, 5. Same deal. Nothing any different. x1, y1 is minus 2, 7. x2, y2 is 4, 5. That's the formula that you will have learned. y2 minus y1 over x2 minus x1, the change in y over the change in x. Substitute the numbers in. Be careful with the minus signs. That is, the main mistake people make in these questions is minus sign carelessness. 5 minus 7, 4 minus minus 2, and we evaluate that as minus 2 over 6, or obviously minus 1/3. Because it's always a good idea, indeed the right idea, to simplify when possible. We can also work in more general terms, calculate the gradient of a line which passes through 2d, minus 5d, 6d, 3d. Exactly the same logic, x1, y1, x2, y2. Use the formula. Every time you answer these questions, write the formula down first and then do the substitution. 3d minus minus 5d, 6d minus 2d, evaluate it, 8d over 4d, and then simplify. The gradient is 2. We can also sometimes have to find a point that gives us the gradient that we want. So here's an example. The line joining 2, minus 5 and 4, a. In this case, this line has a gradient of minus 1, and we have to find out what a is to actually give us that required gradient. Our method's exactly the same. We write down x1 and y1, and always when you answer questions in exams, make sure you write down this information and check it to make sure it's right. x1 y1 is 2 minus 5, x2 y2 is 4, a, the unknown in this case. So the gradient is y2 minus y1 over x2 minus x1. we can do the substitution. A minus minus 5 over 4 minus 2 is equal to minus 1, because we are told in the question that the gradient is minus 1. Bit of simplification. Minus 1 equals a plus 5 over 2, and then that's an equation we can rearrange and solve. Minus 2 equals a plus 5. Subtract the 5, a is minus 7. So the question was calculate the value of a. The answer is a is minus 7. So 0.4 comma minus 7 gives the gradient minus 1. Part 2 of this lecture is finding the equation of a line from the gradient and a point. So we can find the equation of a line using this formula here written in red. Y minus y1 is equal to m x minus x1. It's another formula we need to make sure that we learn and are able to use. But once we've learned it and have seen some examples, it's a relatively straightforward process. Y minus y1 equals m x minus x1. It is of course essentially a rearrangement of our gradient formula. We've times it. We had y2 minus y1 of x2 minus x1. We've rearranged that by timesing out the x2 minus x1. So, example, find the equation of a line with the gradient 5 that passes through the point 3, 2. Well, x1, y1 is 3, 2. The gradient m is equal to 5. Again, write down the facts of the question, then write down the equation. Y minus y1 equals m x minus x1. Substitute the numbers in. That's not in any of the approved forms of a straight line. We don't mind too much with this y equals or the ax plus by minus c is equal to 0 form. Sometimes a question will specify what form they want, in which case you have to give it in the right form, but generally speaking, any way is good. So we can rearrange it, expand the bracket, y minus 2 is 5x minus 15, do some rearranging, and we get y is 5x minus 13. That's a perfectly fine answer. We could have, if we wanted, 5x minus y minus 13 is equal to 0. That would be perfectly fine as well. But it's got to get it in one of the approved ways of writing the equation of a straight line. Find the equation of a line with a gradient minus a half that passes through the point 4 minus 6. We write down the facts. We write down the equation. We substitute in the values. Y minus minus 6 is minus a half x minus 4. This one's looking a bit ugly mathematically, so it needs a bit of tidying up. Let's expand the brackets. Y plus 6 is minus a half x plus 2. That's looking a bit more like it. Subtract the 6. Y equals minus a half x minus 4. That's fine. Or we could rearrange it to be in the other form if we so wished. So that's the equation of the line with a gradient minus a half that passes through the point 4 minus 6. The line y equals 3x minus 9 crosses the x-axis at coordinate a. Find the equation of the line with a gradient 2/3 that passes through a. Give your answer in the form ax plus by plus c equals 0, where a, b and c are integers. There's a bit more going on in this question. Let's read it carefully. So the thought process is, to find the equation of the line, I need to know where a is. Because I've got to find the equation of our line with gradient 2/3 that passes through a, but I don't currently know where A is. So, once we've had that thought, our second thought is going to be point A is on the x-axis, so it have a y coordinate of 0. Any point that's on the x-axis means that y is equal to 0. So I have the equation there already, y equals 3x minus 9. If I put y equal to 0 in that equation, then I can find out where A is. So y is 3x minus 9. I substitute 0 for y. 0 equals 3x minus 9. I add the 9 on, divide by 3. X is equal to 3. So the point A is at the point 3, 0. We have to go through sometimes in A-level maths a thought process. Don't rush into questions. Stop and think what's going to be the best way to approach them. So once we know that A is at the point 3, 0, then we can use our formulas we've seen before in order to work out the equation of a new line. So A is 3, 0, make a little note of that at the top there. Find the equation of the line with the gradient 2/3 that passes through A. So x1, y1 we now know is at 3, 0. The gradient we're looking for is 2/3. We can write our equation down. Y minus y1 is m, x minus x1. And now when we're in the home run now, we can just substitute the values, expand the brackets. But that's not fine because that's not the final answer. That is an okay form for equation of a straight line, but in this particular question, it asks give your answer in the form ax plus by plus c is equal to 0. So we have to rearrange it. If we subtract the y, we get 2/3 x minus y minus 2 is equal to 0. But a, b and c are not yet integers. Multiply by 3, 2x minus 3y minus 6 is equal to 0. That's the approved form of a straight line. In an exam, you should show all of the working out that leads to that answer. Do not try to jump over steps. Do not leave things to the imagination of the examiner. Make sure that you show exactly and clearly you're working out how you get from the question to the answer. Part 3. Finding the equation of a line from 2 points. We can find the equation of a line for 2 points with another formula that we need to remember. It is y minus y1 over y2 minus y1 equals x minus x1 over x2 minus x1. We can get this formula from the 2 previous formulas. I will leave it to your own imagination and a piece of paper in order to work out how you get the 2, but if you know the fact that m equals y2 minus y1 over x2 minus x1, and also you know that y minus y1 equals m x minus x1, then you should be able to rearrange them to end up with this formula here. The process we go through is obviously the same as before. Work out the equation that goes through the points 3 minus 1 and 5, 7. Give your answer in the form y equals mx plus c. We write down x1, y1. We write down x2, y2. We write down the formula. We substitute in the values. We tidy it up by working out any sums. And then we can rearrange it. So once we've rearranged it, we will end up with y equals 4x minus 13. We do need to make sure that we are quite comfortable rearranging expressions and equations in order to get from a nasty form to the form we want the answer in this case y equals mx plus c. The lines y equals 4x minus 7 and 2x plus 3y minus 21 equals 0 intersect at the point A. Point B has coordinates minus 2, 8. Find the equation of the line that passes through A and B. So again, there's more going on in this question. We've got those two equations and they intersect at point A. So in order for those to intersect, we need a thought process. We need to think, we need to find out where is A. How are we going to do that? If the equations intersect at A, then they have the same value for y and x. So if I can write one of the equations in terms of y, I can replace the y in the second equation and solve it. Well, luckily, one of the equations is already in terms of y, because we have y equals 4x minus 7. So if I replace the y in the second equation with that 4x minus 7, I'll have 2x plus 3, 4x minus 7 minus 21 is equal to 0. That's an equation we should be able to solve. Expand the bracket, collect the like terms together. 14x is equal to 42, so therefore x is equal to 3. Once we know that x is equal to 3, we can then substitute that into any of the equations. It's easier to do the 4x minus 7 one to get that y is equal to 5. So now we've got the point A. A is at the point 3, 5. So I'll make a note of that somewhere so I don't forget it. There it is. A is 3, 5. And now we can use the fact point B is minus 2, 8 in order to find the equation of the line that joins A and B. So there's x1, y1, 3, 5. x2, y2 is minus 2, 8. There's the formula we will have learnt by now. Y minus y1 over y2 minus y1 is x minus x1 over x2 minus x1. Substitute in the values, work out the denominators, and then rearrange it by getting a common denominator, timesing it out, tidying it up to get 3x plus 5y minus 34 is equal to 0, which is one of the approved forms of the equation of a straight line.